Yes, dear children, let us see the next topic, free expansion. Now, what do you mean by free expansion? Expansion in vacuum is called as free expansion, okay? Where P external is 0. Nothing is pushing it to expand, okay? And in that case, when it is doing on its own, no work is done, okay? Whether it is a reversible condition or a irreversible reaction. So, expansion in vacuum is a situation where there is no external pressure applied and no work is done. Now you know the mathematical relation for first law of thermodynamics, that is delta U is equal to Q plus W, right? Now if W is equal to minus P external delta V, this equation we have already studied in previous topics. The equation will become now delta U is equal to Q minus P external delta V, right? Okay. Now if the process is taking place at constant volume means what? Delta V is equal to 0. And if delta V is 0, then product of P external into delta V will also become 0, right? So your delta U will become equal to QV. That is, heat supplied at constant volume is change in internal energy. U is nothing but internal energy, remember that. Now, a set of equations which you are supposed to remember what we have already seen. I am just recollecting everything for you. For isothermal expansion of an ideal gas into vacuum, W0 no work done and P external is also equal to 0. Joule, the scientist, he determined experimentally if Q is 0, then delta U is also equal to 0. Okay, if delta U is 0, then from this equation what you consider, if this is 0, then Q will be equal to minus W. Okay, then for isothermal irreversible change, it is Q is equal to minus W. And what is minus W? It is P external delta V. Okay, that is P external into V final minus E initial. So this is the expression for an irreversible change. And if the change is reversible, then it is again the same way Q is equal to minus W. But then here we are going to use the integrated expression, that is nRT ln V final upon V initial. Now what is this ln? It is called as natural log. And natural log, if it is converted into log to the base 10, then we introduce a factor 2.303. So it is 2.303 nRT log V final upon V initial. And if the change is adiabatic, then Q is equal to 0 because heat neither enters the system nor comes out of the system. In that case, change in internal energy will be work done adiabatic. Is that clear? Q is equal to 0. In this expression, Q is equal to 0. So delta U is equal to W. That's it.